So this is lesson 2E, solving quadratic equations. Problem 1, graph both functions in the same coordinate axis. Y equal to 0. It's just really the x-axis. That's y equal to 0 right there. This is the second function here is a quadratic that, again, by now I hope you recognize it as very simple graph that you can do. It's a quadratic because it's the second degree. You know it's a parabola. It's going to move to the vertex is at 3, -4. So the vertex is at 3, -4. 3, -4, and then the a value is 1. So you're going to go up 1 over 1. To get the next point, because this is a value of 1, you can just go ahead and do 2 square it. 2 squared is 4. So it's going to be over 2 and then 1, 2, 3, 4. So 2, 4. And so there's the graph here. This is the graph. And basically what it is when it says to solve a quadratic is to find where they cross the x-axis here and here. So x equals what? X equal what's one of them? X equal what? X equal to 1, and the other one is going to be x equal to 5. Now, I mean, you can verify this solution if you really wanted to. You can verify that it's true. How do we verify that it's true? Just plug it in. X is equal to 1. If you plug in x is equal to 1, you better get a y that is what? A y that is what? 0. That's why they call the zeros of the function. So if I do plug in x equal to 1, which I will, I guess, do it here, is it check off as being true? So I'm saying that it better equal to 0, y 0. If I plug in x is equal to 1. 1 minus 3 squared minus 4. What's 1 take away 3? 1 minus 3 is what? -2. -2 squared. -2 squared is what? 4. And what's 4 take away 4? 4 take away 4, I think, is 0. My check mark checks off. If you want to do it for x equal to 5, plug in 5. Look, I'm going to do it quickly. 5 minus 3 is 2. 2 squared is 4. 4 minus 4 is 0. It checks off at 0. They're called zeros of the function. Okay. So this is the visual representation of what we're doing here. When they tell you to solve a quadratic. So what are the solutions? Sometimes they call it what are the solutions of the function or of the quadratic, or they find what are the roots. Sometimes they find what are the x-intercepts. These are all kind of represent the same thing. Solutions, roots, x-intercept. And the solutions are x equal to 1 and x equal to 5. If you want to put it as an ordered pair, you can say this is a point on the graph, which is 1, 0, and this is a point on the graph, which is 5, 0, where x is 5, y is 0. So this is the visual representation of what it is, no? To solve. I almost want to skip this problem because, I mean, look, y equal to 0 is right there. To graph this one in standard form, you want to put it in vertex form, which I'm not going to do. That's going to be, we already did that. That takes too long. Okay, so then that is the graph of this second function here. And the solutions are going to be x equals, what are the solutions? X equal -3, 0 as a point if you wanted to. And the other one is 1, 0. One more time, I can go ahead and plug in I can just plug in x is negative 3. X equals negative 3 here. That would be what? Negative 3 squared plus 2, negative 3, minus 3. Then it's going to be what? 9. This is minus 6, minus 3. 9 minus 6 is 3. 3 minus 3 is 0. So it equals 0. Yes? Yes? Okay. So, and then plug in the other one is going to work out to be that. Those are the solutions. Okay. Negative 3, 0, 1, 0. So I'm going kind of fast here on this one because we got to get to the actual ones we're going to do, and I'm going to show you how to do those. This one, you don't have to copy it down. I got to continue. I got to get fast. I got to go. Just kind of like, just know what I'm going to do here. I'm going to go, the vertex is at 3, 2. It's at 3, 2. It's right here. And the A value is 1, so it goes like this. So what are the solutions of this function? It's supposed to say no real solutions. It has no real solutions. No, son, don't be eating. They make it too much noise here. No real solutions. Because it does have imaginary solutions. I don't know if you remember this from Algebra 1 about imaginary solutions. Who remembers? Raise your hand if you know that. Imagine the I. You remember doing that? All right. In any case, this one has no real solutions, and in next week we'll start doing imaginary. Not this week. Imaginary solutions. It has no real solutions because it will never cross this axis. It goes on forever up and then will cross it. Never cross it. Okay, so solve the following quadratic equations. Go ahead and write this down. Problem number 4. What I'm gonna say again about my method and the way I do this is a summation. It's a collaboration of my ways of teaching and what I've learned from prior students, prior years, 7 years, maybe now it's longer, where I had students that would ask questions about how I do it and how I can, how it's just, we can get answers very quickly. So here it says to solve the following quadratic equations. And we're going to solve for what x value we get a y of 0, which is finding the roots, finding the solutions. And we will continue on doing my method of doing the x. Let's do the x. So what goes at the bottom of the x? Everybody, anybody? 6. And what goes on top? 8. This is as easy as we can do. What are the two numbers that multiply to the top, add up to the bottom? 4 and 2. This is, I'm not trying to make it like very hard. Like this is so easy. 4 times 2 is 8. 4 plus 2 is 6. And so we're going to write down the factors. And the factors are going to be what? X plus 4 and what? X plus 2 and it's equal to 0. Mathematically speaking, why does this work? This is called the zero product property. Why is this zero product property? Because this is the idea. Look, if I have something equal to 0, no? Something, well, it's equal to 0. And if I have any number, say for example, I got any number here, no? Any number, not 0. Let's say this is 5. The only way that this is going to be true, that I multiply 5 by something, 5 times something gives you 0. What is this something? 0. Yes or no? Do you understand that? 0 times 5 is 0. That's just logically what it is. So if I'm saying that this is 5 right here, this is 5, whatever it is, then this better be, if this is some number not equal to 0, it's like 5, and this better be equal to 0. And so if this is equal to 0, if this equal to 0, the expression, what must x be? Negative 4. So negative 4 plus 4 is 0. 0 times anything is 0. Okay. All right. That's the idea behind it. So you're still sitting there like, I don't understand what you just did. Okay. Basically, what I'm going to tell you is that x plus 4 better be equal to 0. and or x plus 2 better be equal to 0. That's how you do it, okay? And then I solve for x. How do I solve for x here? How do I get the x by itself? Subtract 4, subtract 4, subtract 4. So x is equal to what? That's what we just said without doing any work. And what do I do here? Minus 2 is going to be x equals what? Yes? Yes. Now, I have to teach this whole thing. I have to do this whole thing. But I always get some really bright kids who rather not do a lot of work. And he says, well, that's a lot of work you're doing. So I was like, how do you find it faster? The answers are already here. The answers are already here. The answer is going to be x equals what? Negative 4, and x equals what? I didn't really, I kind of did, but I have to teach the whole thing. But a student said, hey, you can just do it quickly by doing it like that. But I have to teach you all this because that's the standard way of doing it. All right, let's go to number 5. So to solve quadratics, like problem number 5, it has to be set equal to what? 0 if we're going to use this method here. So how do we set it equal to 0? Subtract 9x. Yes, we're going to subtract 9x so it can become 0 on the right side. And then we do this x here. What goes at the bottom of the x? Negative 9. What goes on top? 18. So what are the two numbers? Negative 6, negative 3? Yes? Negative 6, negative 3? I have to explain the zero product property. That's why it works. But what's the answer then if you believe in that zero product property? What's the answer? X equals what? And x equals 3. And if you don't believe me, you can go ahead and plug in 6 and work it all out, and it will equal 0, or whatever it's going to be. It'll make a true statement. You know? Okay, let's go to number 6. Well, definitely we're not going to do it like with the X method here. For sure, we're not. Why are we not going to do it without? Because it's missing what? The X? Yes or no? It's not that I forgot to put it in. Or you forgot to put the X there? No, I didn't. That's just the problem. So what should we do? Just solve for X, no? So how do I solve for X? What should be step number 1 in getting the X by itself? Can we get rid of minus 31 to go to the other side? How can I get the minus 31 to go to the other side? Can we plus 31? We're not doing it like the other problem we just did. 4x squared equals, what is that? Is that 80? Yes, it is. What's the next step? Divided by 4. Um, 80 divided by 4. 80 divided by 4 is 20. Now what do I do? Square root it. Square root it. So x is going to equal 2. You know what I'm going to do? I'm going to go ahead and talk to you guys about this. That square root of 20 can be broken down Well, you can actually plug in square root of 20 into a calculator, and it's going to give you something like what? 4 point something, no? We don't want that. We want to keep it as something like this. So now, what are two numbers that multiply to two numbers multiply equal 20, where one of those numbers is a perfect square number? And say it first. What is this perfect square number multiplied by some other number, and they multiply to equal to 20? What is this number right here? Isn't it 4 times 5 is 20? Yes? And what is the square root of, because this is going to become square root of 4 times square root of 5. What's the square root of 4? 2 square root of 5 is the answer. We cannot break down the square root of 5 anymore, because that will be only 5 times 1, and square root of 1 is 1. It doesn't do anything. Square root of 5 is square root of 5. So this is the answer. What did I mess up on, and what should I have right in the front? What should I have in front of 2? Okay, whenever you take a square root of, and it's an equation, you better put a plus and minus, plus or minus. So you need to put a plus or minus here. So there it is. So it's plus or minus 2 square root of 5. Take a square root, plus or minus 2 square root of 5. Or let's go. Number 7. I mean, here, I could we can just have a little bit of 5 minutes. I'll give you 5 minutes here. You solve it yourself. Let me see how do you think about it in this math. How do you solve for x here? See, sometimes you just want to be, can you teach me how to do it? Let me see if you can think of how to do it by yourself. You know, other classes I'm doing at CFA, and it seems like it's going forever. Like, time passes so slow. And in this class, we're almost done. 20 minutes. And let's see. Who got the answer? Let's see who got the answer. I thought some people would be doing. Let's see here. Yeah, there you go. That's a lot of work, though. All right, you know what? Because let's stop. I just had you. I wanted you to think about how to attack or do this problem and solve it. Look, everybody, look up here. I don't know, because I already see, and I didn't walk around, but I already see people doing what I thought you would be doing. And but anyways, I want to get the x by itself. I got to get rid of this 2, first of all, for sure. Let's get it. So what's the opposite of times, everybody? This is the way I'm going to do this problem. X plus 3. I'm just going to do inverse operations here. That's 2. How do I get rid of that power of 2? square root it. I'm going to square root it. Because opposite of squaring it is square rooted. So then this is gone. Plus or minus square root of 2. And then I'm going to minus 3. Minus 3. So x is going to equal to negative 3 plus or minus square root of 2. That is going to be a problem like that on test. I'm just letting you know already. There's going to be a problem like this on the test. Pretty sure. I don't know. Some of you guys doing it another way, which is fine. Well, but it just takes longer. But it would work, maybe. I don't know. But that's the way you would do this faster. All right, let's go to number 8. Yeah, let's go. Number 8. It's missing the constant. I would just bring it over. Let's just, yeah, I'll just bring the 6 over to this side. X squared minus 6x. Factor out an x. Yeah, and then use the zero product property. Or else, I mean, you can do the x also. But I factor, it's called factoring. Do a GCF. The greatest common factor is x. And so you're left off with x times x squared, x times negative 6, 0. So then we can use the zero product property. X is equal to 0 or x equal to 6. Because like I just said, if x is 0, 0 times anything is 0. And then here x is 6, 6 minus 6 is 0. 0 times anything is 0. Okay, let's go to number 9. So you're gonna move everything to one side. Should we move everything to the left or to the right? I'm going to move everything to the right because the biggest power is x squared, and that 2, so I'm going to move everything to the right because that x squared, there's only one x squared over here, and I want to keep it positive. So I'm going to move everything to the right. This cancels out. I'm going to add x here to this side. And that cancels out, and then I'm going to minus 28. I'm going to minus 28 over here. And put it in order. So this whole thing cancels out. So on the left side is 0. Then I'm going to put the highest power. 2x squared minus 1x squared is going to be x squared. And then I have 2x and 1x is 3x. And then I got a minus 28. Then we could just do the x here. So this is going to be 3 and negative 28. And what are going to be two numbers here? Negative 47. Negative 4 times 7. Negative 4 times 7 is negative 28. Negative 4 plus 7 is 3. And can we get our answers from there already? Yes. The answer is what? Positive 4, and then x equals negative 7. And here's the last problem for today, number 10. Find the value of x. The area of the rectangle is 48 square feet. Yeah, from geometry, what's the area formula for rectangle? Do you remember what's the formula for finding the area of a rectangle? Is it base times height, or is it length times width? Does it really matter? But it's length times width. Let's go with length times width. But you know they're just letters. Base times height, I guess, would work as well. All right. So area equals length times width. And we already know what the area is. Area is 48, no? 48. And then we got length is x plus 2. Times the W is x. We can go ahead and distribute. So 48 is going to equal 2x squared plus 2x. Then what do we do? Minus 48. So we're going to set it equal to 0. So we're going to have x squared plus 2x minus 48. I mean, we can do the x. We're going to do this x here. 2 at the bottom. Negative 48 on top. What would be this? 8 and 6? 8 and negative 6? And the answers are going to be what? What would be the answers? X equals what? Negative 8 and x equals what? X equal to 6. But which one is the actual answer for something that if it's going to be true? It would be, because if I plug in x equals negative 8, I'm going to go get negative 8 plus 2, which gives me a length of negative 6. In what world do you live that you can measure and be negative 6? Makes no sense. Not correct. So this wouldn't be an answer. X equals 6 is an answer, because then that would be 6. 6 plus 2 is 8. 8 times 6 is 48. So the answer is going to be 6. All right, that's it. We're done.